So everybody can say hi to the camera, say hi to the camera. That's aluminum. I guess I'm going to include the states in there. Plus H2SO4 aqueous. I'm just writing this equation over here, okay? So we want to write it also. Aluminum, SO4, 3. Aqueous plus H2. Now we're going to balance this equation. First, count the atoms that we have on the left and that we have on the right side. This is, let's see. Oh, it's mirrored. Oh. Okay. How many elements or what different kinds of elements do we have in here? We have aluminums. I like to put them in the center, right? Aluminums. What else do we have?
Hydrogen.
We have hydrogens. And we have sulfurs. And we have
Oxygen.
oxygens. And those are all the elements that we have, right? And they should exist in both sides. So we count the right side, we also have aluminum, we have hydrogen, we have sulfur, and we have oxygen. Same, right on left and right side. Which of those are we gonna balance first? Which occurs only in one compound on both sides?
The right side?
Can you see aluminum happens in one compound in both sides? Yes. It happens here, and it happens here, right? But can you also see that aluminum is by itself?
Yeah.
So it should balance last, right? So this, we can balance first, we can balance last. Let's try to find an element that is actually occurring only once on both sides, right? What about oxygen? Can you see oxygen occurs once in both sides?
Yes.
So maybe we can start with oxygen in this case. Can we start with sulfur also?
Yeah.
Yeah. Can we start with hydrogen?
Yeah.
No,
Yes, because it's only one.
over there.
It's by itself over there, right?
Yeah.
So we might try to balance this towards the last. But for sure, oxygen or sulfur, we can balance first. So, well, I'm going to leave this order. I'm just going to put a, well, let's write our order here, right? Balance sulfur then, oxygens, and then it says balance metals before non-metals, right? So I'm going to choose aluminum, and then H2. Let's see if we can balance this, right? Again, this balancing method is trial and error. Trial and error. If you can do it with pencil, that's better. Okay? Because we're going to be erasing or scratching. That's fine. If you want to use pen, that's fine. Just make very legit scratches that you can read in there. Yeah. Those are going to be scratches, like legal scratches. You can see what's underneath there because you need to know where that scratch, why you scratch that. Right? So let's start with, let's count all the atoms first. How many aluminums do I have on the left side?
Is that a 5 or is that an S?
We're counting aluminums. What?
Is that a 5 or is that an S?
Oh no, those are the states. Well, I'm going to get rid of the states so it's not confusing. We don't need those, right? States are only going to tell us if this reaction is gas evolution or whatever. Just going to get rid of the states. There's only one. There's one aluminum, right?
Mm-hmm.
So I'm just going to put a number 1 in here. Can we see that down there? Yeah. It's number 1. How many aluminums do I have on the right side? 2. Can we see we have 2 aluminums? Okay. How many hydrogens do I have on the left side? 4. 2. How many hydrogens?
2.
Oh, yeah. Right. The left side I have 2 hydrogens. And how many do I have on the right side? 2. Looks like 2, right?
Yeah, it's 2.
Okay. So we're good. How many sulfurs do I have on the left side? We're not balancing yet, right? We're just counting. How many sulfurs do we have on the left side?
1.
It's just a 1. And how many do I have on the right side?
1 of 3.
How many do I have on the right side?
It's 3.
So we bumped into what we call a polyatomic ion. right? This SO4, it's always going to come together as an SO4. And there's 3 units that are called SO4. So if I have 3 units and each of them has 1 sulfur, how many sulfurs do I have in reality? 3, right? So this subscripts, you also multiply those. Okay. How many oxygens am I going to have in here in case when we count, right?
No, 4 times 3.
Which is what? 12, right? And how many oxygens do I have on the left side?
4.
Do we all agree on that 4? Right, 4. Now, we do this analysis because if it's already balanced, we don't even have to put numbers in here. We don't even start. Can you see it's not balanced?
Yes.
So now let's start with the order. Let's try to balance our sulfurs, right? So all we have to play with, all we can play with is the big numbers that go in front of the equation. Only the big numbers that go in front of the equation. These small numbers we cannot mess up with. They have to stay there. Okay. So we're starting with sulfur. There's 3 sulfurs in here. There's 1 sulfur in the left. How do I make these 2 numbers the same? Oh, we're not moving. If I borrow 1 from here, I'm going to change these numbers. And we cannot change those numbers. Everything that's written in there, we cannot change.
You multiply the left side by 3.
And we're going to do it through multiplication. Okay, through multiplication. So what happens? What happens if I multiply? What happens if I multiply this molecule times 3? Let's say I had 3 of those molecules. Is that balance out the sulfurs?
Yes.
Do I have 3 sulfurs now?
But
Right.
now it unbalances your hydrogens.
Did we balance the sulfurs first?
Oh, yes.
Yes, right? Which is what we're trying to do, balance the sulfurs, right? Are we messing up everything else? Yeah, that's how we start. Right? Balancing the sulfurs, that has to be balanced first. Can you see that's a 3 times 1?
Yes.
So now we have how many sulfurs? 3 on the left side. Sulfur balance? Yes. If you change a coefficient, one of these numbers, you gotta check again. You gotta count, do the counting again. Because can you see we also change the number of hydrogens and we also change the number of oxygens. This is a trial and error process. It's always gonna be like that. That's how it is, right? So we put a little bit here, but we unbalance everything else. So what's the new number of aluminum as well that we didn't even touch? So that's gonna remain the same right now. How many hydrogens do I have on the left side?
6.
I have 6 now, right? So this is not a 2, that's a 6 already. That's fine. Sulfurs, that's fine. How many oxygens do I have on the left side?
How many what?
Oxygens.
On the left side?
12.
Uh-huh.
12.
Yeah, 3 times 4. So now that's a 12. Okay, that's where we stand right now. Is the whole equation balanced?
No.
No, not yet, right? But we balance the sulfurs. Oh, and we balance the oxygens also, right? So that's step 1. That's step 2. If not, then we'll have to analyze the oxygens, right? And what are we going to do about the oxygens? So what's next to balance?
Aluminum.
Aluminum. Can you see aluminum is very easy to balance here? What do I have to do?
Multiply by 2.
I have to multiply my aluminum source.
Yeah, we'll multiply
Okay.
by 2.
Everything's through multiplication. Okay. So if I add a number 2 in here, can you see I balance the aluminums?
Yes.
Did I mess up something by putting a 2 in here?
No.
Something else? That's why we leave the elements by themselves at the end. Right? That's why. So what's the only thing that needs to be balanced?
The hydrogens.
Now we need to balance hydrogens, right? I have 6 on the left side and I have 2 on the right side. Can I add to the right side? Yeah, we can add to the right side. What number do I have to put in here so that it has the same number of hydrogens left side and right side? If I put a 3 here, 3 times 2, my new number 6. Did I miss something else? Because if I did, I have to change it.
No, it's by itself.
Alright, it's by itself. That's the good thing about elements by themselves. And this is where you want to put the fractions, in the very last element. If this is the only one that you have to balance, you can rely on fractions, right? That's not a whole number. Then at the end, you multiply the whole thing times the denominator. Okay. Is this reaction balanced now? We have to do the counting again, right? So I'm going to get rid of these numbers. So I'm going to recount, just to make sure that we actually balance it. How many aluminums do I have on the left side? 2 times 1. And on the right side, 1 times 2. Right? Hydrogens, 3 times 2. And hydrogens over here, 3 times 2. Sulfurs, 3 times 1. And sulfurs over here, 1 times 3. Three of those, right? And if I have another number in here, that's 1 times 3 times 1. Still 3. Oxygens, 3 times 4, 12, and over here that's the same, right? 4 times 3. So that's balance. It's trial and error, it's crashing, it's racing, it's going back to the start. That's how it is. That's the most that I can give you about rules. That's the most. Everything else is
wondering.
is
Yeah,
already-
question. The order over there, the 1 to 4, how did you get that?
How did I get that? So we get into the rules, right? Remember that the rules say, and since we are recording, I have to get the screen down, right? So Miguel is asking, where does this numbering come from? Off now. Come on. We're live.
Coffee sounds good. And a donut.
So where does that numbering come from? These are the rules, right? We start with elements that occur only once in both sides. In 2 compounds, just once, not on several compounds. Right? So that's why we choose sulfur to be first, because it occurs in 2 compounds, both sides, right? I give you the skeletal equation. Right? Sulfur is in 1 compound, and sulfur is in 1 compound. And then we move with oxygen because that's also an element that occurs in only 1 compound and only 1 compound on both sides. Could we start it with oxygen and then sulfur? Yeah, it will be the same result. And then we choose the elements that are by themselves. We have aluminum by itself and we have hydrogen by itself.
So as long as the numbers add up at the end.
Yeah, as long as the numbers add up at the end. You can start with whatever you want. If you think it's easier to start with hydrogen for some reason, go ahead and do it. Right? You can follow any method that you want. But these rules that I gave you, I think it's the shortest way to do it. Okay, shortest way to do it. So let me open the work that the worksheet that we were doing, so I can give some examples in there. Okay, the worksheet that is learning that says balancing equations for practice. I want to take some examples from there. There's only one example that comes in the PowerPoint. And of course, we're going to do some more examples, right? I want to do some more examples. Looks scary, but believe me, it's not that scary once you get to know how to do this, which is not, there's not a universal rule of how to do this. It's not mechanical, so you have to think about it. Yeah, I'm adding here, should I add on this side or should I add on the other side? What's going to be better, right? So it's a lot of fluctuations in the science behind this. That's why people don't like to balance, because it's hard because it's not repetitive. Every example is a different example. It's not going to be the same. Right? So I'm going to start with this equation over here. Iron plus Cl2 produces iron trichloride. How many elements do I have on both sides?
2.
So only 2 repeating elements, right? I have iron and I have Cls. So the only elements I have.
We're doing the A, right? We're doing the A.
Yes. So what should I balance first? Well, both elements occurs only in 1 compound on both sides, right? So, and both of them are by themselves. So the answer is, it doesn't matter. Oh, we actually have to balance metals before non-metals, right? So we can start with iron and then end up with chlorine. It's not gonna make a difference at this point, right? That's fine. If you wanna follow the rules, yes, balance iron first, right? Let's go ahead and do it. Let's follow the rules. We balance iron first and then chlorine. There's a reason why I didn't want to balance iron first, right? How many irons do I have on the left? 1, and the right? There's 1, right? That 3 only applies to the chlorine.
Oh.
If it was like this, then it applies to the iron also.
Oh, okay.
Okay. How many chlorines do I have on the left side?
2,
2, and on the right side?
3.
3. That's why I didn't want to start with iron, because that's already balanced, so I have to move to chlorine anyway. Right? So let's start with iron. Iron's already balanced, I don't do anything. We move to chlorine. What am I gonna do in this case? How do I make those 2 numbers equal? Because it has to be through multiplication.
You have to multiply both sides, no?
Can I do that?
Yeah.
Sure, why not, right? How do I make this? The whole point of this is making these two numbers the same. Right, so how do I make those two?
You can multiply the right side by 2 and then the left side by 3.
That's clever. Right? Do you see what he's doing in there? Is he gonna make these two numbers the same? Yeah, right? So when you have a 5 and a 6, you're gonna multiply this times 5, this times 6. Right? If you have a 4 and a 10, you're gonna multiply this times 10 and this times 4. Right? If of course it's not easy to just multiply one side times 2 and that fixes it, or multiply the other side times 3 only and that fixes it, you can do this, right? You multiply times the opposite numbers. So let's do that. I'm gonna multiply my chlorine source on the left times 3. Right? And I'm gonna multiply my chlorine source in the right times 2, the opposite numbers, right? Let's count. Can you do this? Can you do 2 at a time? Yeah, you can do that, right? We have to count again. On this side, I messed up the chlorines, right? I don't have 2. How many do I have now? 3 times 2, 6. And that's the whole point of putting a 3 in there, because I want to convert both of them to 6s. On the right side, 2 times 3, that's 6. But can you see we messed up something else
Yeah.
in there? So what's my new number of irons in here? 2 times 1,
So you
2.
multiply the left side by 2.
You see the last step, right? It's very obvious. I have 2 irons on the right side. I have 1 iron on the left side. I multiply the left side times 2. And it comes to 2, and that's balance. Right? Yes. So, can you see this was way different than the first one? It's always going to be different. That's what makes it hard. It's always different. So it's always new. Every single time you see an equation, it's new. And we have to deal with that. Right? So let's do number B. So you should say, Mr. B is not a number. B is not a number. Let's do the second one. Oh, and it gets intense. That's fine. It looks intense, but it's I think. Stop. I think even this one is easier than the first one. You'll see. This elements, iron and oxygen. Iron and oxygen. Both sides, iron and oxygen. So now let's decide what we're going to balance first. What we're going to balance last. There's just 2 elements, right? So both of them occur by themselves, 2 compounds. Both of them are by themselves, and both of them occur once in both sides. So we gotta balance metals and then non-metals, right? So metals and then non-metals. So let's balance iron. Well, let's count. There's 1 iron on the left. There's how many irons on the right? 2. 2 times 1, right? There is how many oxygens on the left side? 2, and in the right side? 3. So we have our numbers, that's not balanced. Let's start with metals. So what do I have to do to balance the iron?
Multiply the left side by 2.
If I multiply this times 2, can you see that balances iron? Is this? And we're good? Are we balanced already? No, we still have to move to oxygens, right? So what do I have to do to balance those oxygens? Yeah, times 3 the left, right? And times 2 the right. Is that gonna fix it? These 2 numbers? Get them opposite, right?
Yeah, it's gonna fix, but it's gonna mess up the irons.
Don't worry about it, we'll go back, right? It is about trial and error. It is about going back, right? Don't be afraid of messing up everything else. Just take it step by step, be consistent, right? So I'm gonna try to convert this into a 6 by multiplying this times
By 2. And then by 3.
times 2, okay? So my new number of oxygens is 6, 3 times 2, right? And what else did I mess up here?
The iron.
So what's my new number of irons?
6.
2 times 2, that's 4, okay. But then don't lose focus, right? We're trying to convert this into a 6. So we gotta multiply this side times 3. So that converts the oxygens into 6. That's fine, we balance the oxygen. Did we mess something up in this process? Yeah, is that a big deal? No, right? you just go back. So what do I have to change this into so that this becomes a 4?
2.
Right? What if I change this 2 to 4? That converts everything into a balanced equation. It is about erasing, scratching, and put it again, scratching and put it again. It is about that. It has to be like that, right? Trial and error. There's no rule that's going to give you. Well, there's actually a mathematical method too. That's going to give you those 4, 3, and 2 numbers exactly. But it's mathematical. It has to do with algebra and x's and y's and z's and numbers and letters and equations. Maybe we don't want to do that.
Yeah.
Right? So, should we do number C?
Yeah.
Should we do number C and then you guys can
Practice. Try to practice.
try to practice? Just gonna leave it like that. Okay. Questions, Chris? Okay, we're good. This guy is good. This is C, right? That's the one that we're doing. Yeah, we already did this too. So elements that I have here. Iron, bromine, hydrogen, sulfur, oxygen. That's a bunch of elements in there. That's perfectly fine. Let's see what we can do. Okay. So let's choose the order to balance these guys. What's the first rule? Whatever occurs by itself on both sides, balance lasts, and nothing is by itself. Whatever occurs only once on both sides, we gotta balance first. Is iron once in both sides?
Yes.
The iron is here and iron is here, right? So that's good. Is bromine once in both sides?
Yeah.
Yes.
Yeah, right. It's once. It's only on this compound and it's only on this compound. Hydrogens? Yeah, right. What about sulfurs
Yeah.
and oxygens?
Yeah.
Right. So what does this mean? Well, we go to the last rule. Metals first and then non-metals. So what's the only metal present in all of this chemical reaction?
Iron.
Iron. So we start with
Iron.
iron. That's the number 1. And then we move to non-metals. The way I like to do it, there's no particular order in here, but I like to balance, for some reason, I like to balance oxygens last every single time. When I have to, when we go over all of this and it doesn't matter, I like to do oxygens last. Just, I don't know. I don't know, I feel like oxygens, they always happen in like big numbers. And I just want, I don't know. I don't want to do it first. That's the reason. When you go over all the rules, of course, if oxygen is the only one that occurs once in both sides, you have to do it first. Right? But once once it doesn't matter, I like to do halogens. And the last thing that I want to balance is hydrogens and oxygens. If you want to do it some way different, that's fine. That's fine. On this case, as long as it's iron first, everything else is last. See, and this is also a thing that you have to take in consideration, right? I might start this way, and then maybe towards hydrogens, I might get a little bit tricky.
Or sulfur.
Oh, we're missing sulfur, right? So I'll go ahead and introduce it here. That makes no difference, right? Thank you. Makes no difference. But again, if I'm balancing, for example, I'm balancing sulfurs, and at this time, everything gets kind of obscure. So I'm like, my coefficients are 11 and 12 and 16 and then 11 and it's not balanced and everything's messed up. It's a good thing to start all over and switch one of this, right? Instead of making sulfur third, let's go ahead and make hydrogen third. Let's see if I can reach the answer faster. If it gets obscure by you're growing so much in numbers and nothing's been balanced and now you're all crazy because nothing makes sense. Start all over, that's better, right? Most of the times, these equations balance up super simply, super quick, super simply. It doesn't get obscure. Okay, so let's start with irons. Well, let's count everything. So how many irons do I have on the left side?
1.
Uno. And right side?
1. 3.
1 or 3, or neither.
2.
2. 1.
Oh,
Right. This 3 only applies to parentheses, right? There's 2 irons. How many bromines do I have on the left side?
3.
1 times 3. And the right side? There's 1 all the way there. Hydrogens? Sulfurs? Yes, 1 and 3? Do we see where we have 3 sulfurs on the right side?
Because of the 3 on
Because of the 3 outside. Oxygens? Let's see if we get the same numbers.
4.
4 and 12. Do we all agree there? Is balancing really hard? Is it making sense?
I don't know.
Up to now, it's making sense, right? This is where we might get obscure when we have a bunch of elements, so be careful, right? If it starts getting obscure, we have to decide, maybe we'll try another path, since we have plenty of paths to follow, right? Iron, I'm balancing irons, right? That makes this iron and 2, and what did I mess up with?
The bromine.
So I messed up bromines, right? So that's 2 times 3. Okay, so that balances iron. Now I can move into halogens. How many bromines do I have on the left side? 6. What do I have to put in here so I have the same number? 6, okay. What else did I mess up on the right side by putting the 6 in here? So I have to keep track of that, right? If you mess up something, fix it right away. So there's 6 hydrogens now, right? We're following?
Yes.
So up to now that's fine. What's the next thing to balance? There's a 2 here, there's a 6 here. How do I make this a 6? And 3 here, right? That makes it 3 times 2, that makes the hydrogen 6, right? What did I mess up with?
The sulfur.
Sulfurs and oxygens, right? Let's fix them. What's the new number of sulfurs?
3.
1 times 3. And what's the new number of oxygens? 4 times 3. Oh, look at those numbers. Right? Look at all those numbers in there. Balanced. See, what looked like it was going to be a mess just flows smoothly, right? Follow the order. Metals first, non-metals after, if every other rule is already killed. Right?
Magic.
It's magic, yeah, it's magic. So, what number goes in here?
2, right?
1.
2.
No, we didn't put any number in here, right?
Just 1. Just 1.
Yeah, because
If
it's
there's
already
one-
at
I thought
2.
because it was a 2.
No, there's a
Well,
2 here.
there's already a 2 on this side.
I'll go ahead and double check again, right?
No, you don't have to. It's okay.
Huh?
That's fine.
We don't have to? Well, we have to check. It's so smart to check. Right? How many irons do I have on the left side?
2.
There's 2 irons, and on the right side?
2.
1 times 2, right? Bromines? 3 times 2, that's 6. 6 times 1? 6. If there's a number, that's a 1, right?
Yes.
There's no numbers in there, those are 1s. Either the big ones or the small ones. Hydrogens, there's 6. And of course I put a big 6 in here, so it's gotta be 6. Sulfurs, 3 times
Times 1.
1.
3 times
1 times 3.
3.
Times 1, right? 3. Oxygens,
3 times 4, 12.
12 and 12 on the
On this
4 times 3, right? So it's balanced. Those are the numbers we're looking for. Should we do another one, or you guys want to do a hand on that?
Let's do another one.
Let's do another one. Let's do number D, right? It's the number D. The number D here. What is that? That's a bunch of atoms in there. Right, for this one. So let's see how it goes. CH4, C4H6O3 plus water produces C2H4O2. C2H4, oh god. It's a bunch of. I want to say this on a level of 1 to 10 of difficulty, being
A 7.
1, the first one that we did, right? This one. What about this? That's 1. That's also, I want to say that's a 2. I want to say that's a 2. That was easy. I want to say this is a 3. Because there's a lot of elements in the same molecules, and it might be confusing, but let's follow the rules, right? Elements, carbon, hydrogen, oxygen. Let's count. Carbon's on the left side.
4.
And we see there's 4 carbons. Every single time that Belen erases it, the phone goes like.
Oh.
They're gonna say, what's happening? Okay, so 4 carbons, that's fine. I was just messing. 4. How many carbons on the right side?
2.
2 carbons, right? Hydrogen's on the left side.
Oh, 8.
You will see why there's 8 hydrogens
Yes.
on the left side.
H2 and H6.
Right, there's 6 here, and there's
2 here.
that's how many? 8. How many do I have on the right side?
4.
4. Well, I might give this one the difficulty of 4 because when you're gonna change the hydrogens on the left side, where are you gonna put the coefficient? You're gonna put it here or here. So we have to decide right at some point.
Damn.
Oxygens, how many do I have on the left side?
3.
Okay.
4.
3,
4.
4,
And then 2.
and then 2 on the right side. What are we gonna balance first? Nothing is by itself, so nothing has the right to be balanced last.
Carbon.
What occurs only in one compound on both sides?
Carbon.
Do we all agree on carbon? That's the only one, right? Because oxygen and hydrogen, they occur
Twice.
and everywhere, right? So for sure, carbon's first. And then what's next?
Hydrogen and then oxygen.
Hydrogen and then oxygen, right? Can you balance oxygen and then hydrogen? Sure, you can do that, right? I don't mind.
It's under.
It's
on
under
the other
there.
side.
And
Got too excited there.
yeah. Let's start. There's a 4 here, there's a 2 here. Do we all agree we have to put a 2 into this molecule over here
Yes.
and mess up everything? Well, that's how it is, right? There's 4 here, there's 4 there. Let's count everything that we mess up. 2 times 4, that's 8 hydrogens. 2 times 2, that's 4. Oh, oh,
That was easy.
oh. Is it balanced now?
You sure that was a 3?
Huh?
You sure that was a level 3 difficulty?
I don't know, it looked like a level 3, right? It looked like a level 3, yeah. See, I don't really know, like, some of those equations, that's the first time I see those. We're just following the rules, right? You follow the rules and, I mean, if you keep going down, those are new equations, they all follow a different procedure. It looked to me like a level 3 because I was like, oh, there's plenty hydrogens in here, right? So at some point we have to decide where I'm gonna put coefficients, I'm gonna mess up oxygens here. That's the first stop, right?
How about we do a level 3?
Huh?
Yeah, how about we do a level?
Let's do it.
Should we do this one?
Let's do the.
Because that one just like.
Yeah,
flowed
that's
super
simple, that's already balanced, right?
Yes.
So what number's going here?
1.
Just once, right? If there's no number, the handout's gonna ask, what are the coefficients of the equation? So you gotta look for the answer that says 1, 1, 2.
Oh,
Right? 1, 1, 2. Yeah, look complicated, let's
Yeah, it did.
look complicated. Apparently not. Right. Let me just let's see. Because I look at them and they might look complicated, but they may be as easy. Super simple. So because it looks very complicated, but I think it's very simple. Do you guys want to try this?
Sure.
There's a bunch of numbers in here.
Mm-hmm.
See where this goes, right?
which one is that one?
That's I. We're doing letter I. I mean number I, right? Number I. Elements. Hydrogen. Oh God, what's the arrow? Oh, here. Hydrogen. Silicon. It's a new one. It's like carbon. Silicon behaves the same as carbon, so don't panic because this is silicon, right? Then chlorine and oxygen. Make sure that's everything that repeats on both sides, right? Hydrogen, silicon, chlorine, Oxygen, yeah. What are we gonna balance first? Can you see nothing has the right to be balanced last? So nothing's by itself. So what occurs only in one of each side?
Silicone or chlorine?
Silicon and chlorine, right?
Oxygen?
Oxygen, yeah. Oxygen also. So we can balance either of those first. All of them are non-metals, so it makes
Does
no
it really
difference.
matter where you go?
Doesn't matter. I'm gonna follow my order. What do you think I'm gonna balance first?
Silicone.
Yeah. Does it make a difference?
No.
Like silicon, and then what's next?
Chlorine.
Oh, you guys are getting the trend. And then what's next?
Hydrogen and oxygen.
Well,
Well,
oxygen occurs only once, so oxygen has priority,
okay.
right? Oxygen is here, and oxygen is here. Hydrogen is everywhere, right? So that we don't want to balance yet.
Unless it
The
goes
oxygen at
once.
the end, right?
No, oxygen is usually last unless it's only once. So because oxygen only occurs once on either side, we can do that one before we do hydrogen.
These three we can choose, it doesn't matter which one we balance first. They all occur only in one element, in one component, both sides. Hydrogen has to be last, but not because it's by itself, but because it's not balanced first. It's not balanced first. If there was a metal, something like iron only once, then that's the last one, right? For sure. Hydrogen just happens to be the last one because it doesn't fall into the rules.
Wasn't it metals first?
Hmm?
Was
Metals before non-metals, but that occurs only once. Assuming that it occurs only, that is by itself on both
By
sides.
itself, okay.
It's by itself last.
Okay.
Metal and non-metal. That's last.
And it's a free one.
It's a free element, yes. So let's start with, let's count. Hydrogens on the left side.
2, 3.
Should we rewrite this in the order that we're gonna balance them?
Yes.
Silicon, chlorine, oxygen, hydrogen. Just to makes no difference, right? Silicon's on the left side. 1. And oh god, there's 10 of those, right? Let's see if this doesn't get obscure, right? If it gets obscure, we can change maybe Cl and O. Or we can start with chlorines and then silicons, if it starts to get obscure. Chlorines, 3 left and 1 right. Oxygens, 1 in the left and a bunch in the right. 15, right?
So then with the
Hydrogens,
it's 3
3 and 1?
and 11.
Oh, 11, yes.
3, and there's 10 here. Let's see where this takes us. Oh boy. Just as I look at it, I might want to balance hydrogens before oxygens. I always balance, but hydrogens occur everywhere. Okay, never mind. Let's start with silicons. What am I going to put in here? 10. Oh god, it looks kind of obscure now. Let's see. I mess up my hydrogens. What's the new number of hydrogens I have on the left side?
13.
Be careful, right?
Wait, yes, it's 12.
10 times 1, that's 10.
10.
Plus 2, right?
2 is 12.
Okay. And chlorines, I also messed that number up.
So now it's 13.
What's that?
30.
30.
30.
Yes, times. Is this? Times. Oh, so annoying. Okay. And that's all I mess up with this 10, right?
Yes.
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 What's next to balance?
Corn.
There's a 30-to-1 ratio, so what's the number that I gotta put in here? Looks like a big 30, right? That balances the chlorines. What did I mess up?
Everything else.
Hydrogens. What's my new number of hydrogens I have on the
30.
right side? 30.
Wait, 40.
Oh god. That's a 15, okay? So there's a 30 plus 10. Do we all see a 40 here?
Yes.
Yes, 40. I was gonna mess up the oxygens accidentally. That's everything I mess up with this 30, right?
Yes.
Okay. It's balance. What's next?
Oxygen.
Oxygens. So I have 15 here, and I have,
One.
so what do I have to put here? 15? Good. That's good. 15. What did I mess up on the left side? Hydrogens, right? So I have 10 plus. That look like a 40. Right, I have 10 here plus 15 times 2.
Oh.
15 times 2? 30, right? Plus 10.
40.
It's not that obscure when you follow the rules. Right?
Oh.
Yes?
That got a little crazy.
Had you started with hydrogen, you will have never arrived to these numbers. Ever. Ever. Because where are you
Why
going to,
did we start with?
What?
Why didn't we start with hydrogen?
Do you want to start with hydrogen here?
No.
Where are you going to put the coefficients? It's hydrogen's everywhere, right?
Yeah.
So you want to change something in the right side? Do you put it here or do you put it here? You got to choose,
So the
right?
one that has the most, you always leave it for last.
What do you mean?
Like for the
The one that
hydrogen.
occurs in.
Yeah, occurs more.
Yeah.
Leave it for
Unless
last.
there's something that occurs by itself, then that's for sure last.
Okay.
But in this case, hydrogen is last because, not because it wants to be last, but because there's nothing that's going to be last. Nothing by itself. That's why this is last. Because everything else is once in every compound, right? Silicon is just here and here. Chlorine is just here and on the last one, right? And oxygen is just here and here. So that's why they take priority. And then among these three, we gotta choose the metals first. But all of them are not metals. Makes no difference.
So it doesn't matter.
And then whatever occurs a million times, and then whatever occurs by itself.
Okay.
Should we do another one? You guys wanna do the handout?
Can I do it actually later in my console?
Yeah. I guess we can start doing the handout, right? If there's questions, yeah, you can ask them and I can work those out here.
Okay.
Okay.
No nerves. And then we're
Okay.
gonna turn in the.
Everybody say hi and bye, right? Hi and bye.
Hope we feel there.